Okay, so here we are learning about the gas equations. Okay, now see guys, I actually made you do those experiments, and you saw that like how the things are actually changing. So like while doing the experiment one, you must have realized that when you are increasing the pressure, it is decreasing the volume. Okay, you can imagine this thing like with the piston and block system also. Okay, or injection syringe kind of system also, like when there is more volume being added. Okay, so the pressure is releasing. Okay, or like with the increasing pressure, the volume decreases. All right, so they are in fact indirectly proportional, they are inversely proportional. Okay, given that given that there is something constant, and what is that constant? The temperature and the number of moles, the amount of substance, are constant, right? Okay, so based on that, so what you can say is that P is equal to some constant over V. Can I say this?
Yeah.
So based on that, we can say that PV is a constant. Okay, or we can say P1 V1 is equals to P2 V2.
V2, yeah.
Okay, right. So this is the first equation that we get. Okay, if I try to plot the graph for this, okay, you will realize that like if you're plotting P versus V, it is coming out to be like this. Okay, or if you want to linearize it, so P versus 1 over V will be coming like this. Okay, and since P is inversely proportional to V, okay, let me tell you one thing here. When you're plotting ln P versus ln V, or ln V versus ln P, okay, that also will be giving you a straight line. Okay, not this kind of straight line. Wait a second. Ln P is equals to uh, ln K minus ln V. So it will be like this. Okay, this kind of graph you will be getting. Okay, guys. So so it is very, very important to know these things, and this whole thing is considered to be the Boyle's law. Okay, whatever we just learned is the Boyle's law. Okay, anyone having any doubt in this? Easy, isn't it? Right, guys? Sure, let's
Yes,
go
Yes,
sir.
sir.
ahead. Let's go ahead. So now the next law that we are learning, the second law, that is the Charles law. Right, so what is the Charles law? So let's see, what is Charles law? So the Charles law, this says that as you increase the temperature, the volume also increases. Hence, volume is directly proportional to the temperature, given that the pressure and the number of moles are constant. Okay, so these are the constant variables. Based on that, you can say V is equals to some constant into the temperature. So you can say V over T is a constant. Okay, so you can say V1 over T1 is equals to V2 over T2.
T2, yeah.
Yeah, and when you plot the graph of T in Kelvin, remember, very, very important, T in Kelvin versus here the V, okay, then you'll be getting a straight line like this. Okay, but if you're plotting a graph of T in degree Celsius with V, so this will be going like this. Okay, and this thing, this point is negative 273 degrees Celsius, which is equal to 0 Kelvin. Okay, guys. So I hope this is clear to all of you now. Yeah,
Yeah.
super. So let's go ahead. So the next thing, third thing, the pressure temperature law. Okay. Now, pressure temperature law, also known as Gay-Lussac's law. Okay, Gay-Lussac's law. Right. His parents were very happy, so they named him Gay, right? So what does it say? That pressure is proportional to temperature.
Temperature.
Hmm? Given that volume and number of moles are constant, right? So you can say P is equals to some constant into temperature. So P over T is a constant.
Oh,
Okay. So you can say P1 over T1 is equal to P2 over
T2
T2.
over T.
Right? Same way, like the you got volume temperature graph. Similarly, we get the pressure temperature graph if it is in Kelvin, like this. And if it is in degree Celsius, like this. Okay. So both these law actually helps us in understanding that, like, as you tend to reach the 0 Kelvin, okay, the molecular motion ceases, and also the size of the molecule decreases. Okay, it shrinks to zero. In fact, okay. So when you tend to reach the 0 Kelvin, like so far we haven't actually ever reached that temperature of 0 Kelvin. The minimum temperature that has been achieved by human is 4 Kelvin, that is negative 269 degrees Celsius. Okay, 0 Kelvin is still unachievable. Okay, like entering into the black hole. Okay, yeah. All right, guys. So let's go ahead. The last law that we have is the fundamental law for the mole concept. Okay, and what's that? That is the Avogadro's law. Okay, I want to tell you one more thing. Here we go. Avogadro's law. This says uh, uh, that the volume is proportional to the number of moles. Okay, the volume of the gas is proportional to the number of moles of the gas, given that pressure and temperature are constant. Okay, yeah. Uh, So we can say that V is equals to some constant into number of moles. So V over N is a constant. Okay, so we can say V1 over N1 is equals to V2 over N2. So when you plot the graph of for V versus N, you get a straight line like this. Okay. Anyone having any doubt anywhere, please ask. So let's go
No,
ahead.
sir.
Now uh, a complete summary. What we learned here, that P is inversely proportional to V, okay, and PV is a constant, okay. V is proportional to T, and V over T is a constant, okay. Then P proportional to T, then P over T is a constant, okay. Then V proportional to N, and V over N is a constant, okay. Yeah. So basically, you say that P1 V1 is equals to P2 V2, or we say V1 over T1 is equals to V2 over T2, or we say P1 over T1 is equals to P2 over T2. Okay. Or we say V1 over N1 is equals to V2 over N2. Okay. Yeah. So so over here, when you when you basically combine all of these, okay, what do we get is P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. Okay. Now suppose if I'm saying that volume is number of moles and temperature, they are constant. Okay. If I'm saying that number of moles and temperature are constant, okay, then I'll mask these, right? I'll simply mask these, and what we get is the Boyle's law. P1 V1 is equals to P2 V2. Agree? So, and when I say that that volume and the number of moles are pressure and number of moles are constant. Okay, when the pressure and the number of moles are constant. Okay, what we get is V1 over T1 is equals to V2 over T2, which is nothing but the Charles law, right?
Yeah.
Okay. And when I say that the volume and the number of moles are constant, okay, when the volume and number of moles are kept constant, like this,
Mm.
then we get P1 over T1 is equals to P2 over T2, which is nothing but Charles law, Gay-Lussac's law. Okay, yeah. So basically, the point is that whichever is kept constant, that gives us a law, right? Like if we are having something constant, then that gives us a law. Now, this whole thing is equal to a constant, okay? And that constant is denoted by letter R, okay? And this is known as universal gas constant. Universal gas constant, okay? Right. So based on this, we get a equation. Okay. So what we can say that PV over NT is a constant and that is equals to R. So we say PV is equals to nRT. Now what is this? This is the ideal gas equation. It's known as ideal gas equation. Okay. You'll be given the value of R. R is 8.314 when taken in SI units. Okay. Yeah. So R is equals to 8.314. I'll give you the units also. Joule per mole per Kelvin. Okay, right. So 8.314. You don't have to mark this up. You'll be given the values. Right. So this is known as the ideal gas equation. So anyone having any problem anywhere for this? So should I give you the questions, guys?
Yes, sir.
Chalo, let's do the questions, guys. Whatever I taught you today, that will be helpful for you in physics also. Okay, when you do the thermal physics, right? So, so you'll be learning the same thing when you do the thermal physics, right? Chalo, let's go ahead, guys. So, how many of you have taken physics, by the way?
I have taken
I have
physics.
taken.
Even I have taken.
Okay. All right. So, guys, let's go ahead. So here is the question, guys. Okay. So the question is that if for a fixed mass of a gas, mass of a gas at constant temperature, at constant temperature, the pressure is increased by 25%. Okay, calculate the percentage change in its volume. Percentage change in its volume, right? If for a fixed mass of a gas at constant temperature, the pressure is increased by 25%, then calculate the percentage change in its volume. Come on, guys, do it. So, guys, see, the thing is, you are given over here, what you're given is that for a fixed mass of a gas, means number of moles is constant, constant temperature. Okay, so in these two constant conditions, the only formula that we have is Boyle's law. P1 V1 is equals to P2 V2, right? Okay. So when we have P1 V1 equals to P2 V2, all right? So, and since I'm talking with the percentage, so what we can consider is P1 is equals to 100 and V1 also equal to 100. You can assume, right? Why I'm assuming 100? Because we are doing it with a percentage. Okay. Then increased by 25%, that means P2 is 125. And then we are trying to find V2. Okay. We'll see what is V2. Based on that, we'll determine the percentage change. Okay. So the next thing is P1 V1 equals to P2 V2. So P1 V1 is equals to P2 V2. That means 100 into 100 equals to 125 into V2. So with that, you
Yeah.
will be getting V2 to be equal to 80, right? Isn't it?
Yeah.
So your V1 is 100 and V2 is 80. Okay, this means 20% decrease in the volume. 20% decrease in the volume. Simple, right,
Yeah.
guys? All of you understand this,
Yeah.
right? Cool. So let's do the next type. Next type of question, guys. So over here, you are given a few graphs. Okay, here this is P, this is V, okay, and these are the things. Okay, so this is at T1, this is at T2, this is at T3. Okay, for same. So these are three different gases varying differently. Okay, at different temperature, right? Same amount of gas. Okay, so same amount of gas in each case. Same amount of gas. So here you need to determine T1, T2, T3. Okay, you need to use sign this. So fill the box with these signs. Okay, whether T1 is greater than T2 greater than T3, or T1 less than T2 less than T3, or T1 equals to T2 equals to T3, like that. Okay, so that is one question. Okay, second
No, I have
question.
a doubt.
Go ahead.
T1, T2, T3 greater or equal to with respect to the pressure.
Name among themselves. Like, what do you think? T1 is greater than T2 or less than T2? T2 is greater than T3 or less than T3? Like that. Okay. Another one here. This is P. This is T, and we are getting these graphs and different volume. This is V1. This is V2. This is V3. Okay. So you need to here. You need to say V1, V2, V3 for same mass of gas, same amount of gas, same number of moles of gas, right? Yeah. Next is V versus T, and again we are getting three different graphs at different pressures, P1, P2, P3. Okay, so P1, P2, P3. Okay, again same number of moles in each case, and this is V, this is N, right? And this is um, T1, T2, T3 at same pressure. So T1, T2, T3. Okay. So I hope you people understood the question, all of you,
Yeah.
right? You need to fill the boxes with these signs. Okay. Chalo, do it.